and welcome to my YouTube channel. This is Dramani Online Mathematics. If you have not subscribed, please don't just watch and leave. Just subscribe and let's learn together, okay? Yes. And also, it's always surprising that about 300, 400 people watch your video and only two people as just what like it. That is so mind-blowing, right? Say in probably show video now I'm like it. Please just like it and tap like this. That's all. Yes. So we are going to look at the integration of odd and even functions. Okay, I supposed to add functions to this integration of odd and even functions. Like everything is governed by rules, so we need to know this. Good. Now, if f at x is an even function, so first we are going to make or put the emphasis on even function. On the interval negative L less than or equals to x less than or equals to L. So it has closed interval, right? Yeah. Then, so this L here can be any number at all. Then, the integral of negative L to L of this function f at x dx will be the same as integrating it by eliminating the L here and bringing 0 there. Twice of the integral of negative L to 0 f at x dx will also be the same as eliminating the negative and bringing the L here and the 0 here. Twice of it. So what they are saying, we can take an example. So let's take this example and we check whether what this theory or this let me put it that way, is saying is true. So let's consider this example. Integral of let's say, let me make it easy for me. So 3x squared dx. Okay, I'm picking my this thing to be negative 2, positive 2. Because they say L, but one of the limits should be negative, the other should be positive. So that's how I'm having here. So I'm going to prove this to see whether it is true. So I'll start with this one first. So integral of negative 2, positive 2, 3x squared dx. So I know you know how to integrate this. So when we integrate this, we are going to have what? X cube, right? From negative 2 to positive 2. Now, the x cube here, if I substitute, I'm going to have 2 to the power 3 minus negative 2 to the power 3. So for this case, what it means is that 2 cube is 8 minus negative 2 cube will be negative 8. So minus minus. So this one, minus times minus is positive. So that gives you 16, right? Because it's going to be positive there. So 8 plus 8 is 16. Now let's also move to the next theory, because this, they are saying the whole of this is be the same as this one, whilst the limits are not the same. Here the limits is different. So let's see if it is true. But remember, here is multiplying by 2, so it's going to be like 2 the integral of negative 2 here. By the top there, the upper limit is 0, right? Which is 3x squared dx. We know that when I integrate this, I'm going to have x cube. Sorry, there's 2 here already, so let me bring that 2 there. So here will give me x cube negative 2 to 0, right? Good. Which you know better that because here is 0, I will not even do anything with it. So if I put 0 here, everything will go to 0. So I have 2 bracket open. So let me deal with the negative side. So it will be like 0 minus negative 2 cube, right? To be like this, which will give you, now you realize that negative 2 cube will be negative 8. Negative 8 times negative, that will be positive 8. 8 times 2, which is what? 16. Which is exactly this. Yes. Nicely done. Now, let me look at the last one to see whether it's true. So, the last one is going to be 2, then integral of 0, positive 2 here, right? Then 3x squared, the x. That is perfect. So, this is going to be 2. If I integrate this, I'll get x cubed. Remember, these two is multiply. So 0 to positive 2. So the substitution, I'm going to have 2 cube, right, minus 0. Because the lower limit, if I put 0 there, it should be 0. 2 cube is 8. 8 to 16. It is working. Yes. So let's clap for the one who brought that. That is very nice. So we are done. Yes. 16, 16, 16. You know what that is telling you? It's telling you that you can use any of these. The formula is you can decide to use this. Someone can decide to use this. Someone else can decide to use that. But remember, the limits must be the same. It must be when it is 2 here, then it should be negative 2 there. If it is 3 here, it should be negative 3 there. If it is pi, it should be negative pi. Without that, you can't use this. Good. Let's move forward. Yeah, so let's look at for the odd side. If f at x is an odd function on the interval, okay, so this is the interval, the same interval used for the even, then we are saying that for that one, if you integrate it, it will give you 0. I have decided to eliminate the other side, where you said that when you take off the L, then you bring 2 there, it will be the same. Since 1 is giving 0, why do you waste your time to even check that once? If you use it, it will still give you what? 0. Okay. So let's look at an example and see. Example. So let's consider this example. I like simple ones. So let me take simple example like the integral of, so they say odd function. Is it the one that I did? It was even function. So that's why the function I put there was even. It was s squared. And I've already explained to you that s squared is what? Even. Yeah. Now let me take my this thing to be negative 2 again, positive 2. And let me take here to be 4x cubed, the x. Remember, this is odd because x is to the power 3. So it is odd. You can test. You still get odd. Now, if you look at this one, if you integrate this, what are we going to get? Negative 2 4x cubed, the x. I'm going to integrate this. This will give me x to the power 4. Yes. Someone might be saying that, yes, I'm going to take a bigger function for it to solve. This is an example, okay? So I have negative 2 to 2. So if I do the substitution, I'm going to have 2 to the power 4 minus negative 2 to the power 4. So we have 2 to the power 4. Negative 2 to the, so the negative multiply this will also be, sorry, for something sake, I'm going to have minus, I'm supposed to do something here first. 2 to the power 4 is 16. Let me do this first. Minus negative 2 to the power 4 will also give you 16, because any negative number to the power even number will be positive. So this will give you what? 0. Have you seen that? So this confirms the fact that anytime the function is odd, you get 0. You'll be wondering what is the importance of doing this. Don't worry. As you move forward, you see the importance. So let's move to different case. Okay, so now let's look at something. If f at x and g at x are continuous functions, okay, on a certain interval, then What happened? Let's see what happens. Then if f at x is even and j at x is odd, then that is 1, okay? Then f at x times j at x. So let me ask you this question. If even multiply odd, so let's go to the normal terms, primary. So let's take even as positive, okay? Let's take odd as negative. Please, I'm not saying that odd is negative, and I'm not saying even is positive. No. What I'm saying is that let's take it. Math is all about assumptions. So if odd, we are taking even as positive, odd as negative. When a positive multiply negative, what do you get? You get negative, right? So if you are taking odd as negative, it means that if even multiply odd, we get odd. Sharp. So this is what? Then f at x times j at x is odd. You will see the importance of this, don't worry. Point 2. If f at x is even and j at x is also what? Even, then f at x multiply j at x will be what? When a positive multiply positive, you get positive. So when even multiply even, you get what? Even function. Last one. If f at x is odd and j at x is even, then f at x multiplied by j at x is what? So when negative meet negative, no, I've made a mistake here. This one should be odd, okay? I think the other one has already been repeated. When an odd multiply odd, is like when negative multiply negative, you get what? Positive. So when odd multiply odd, we get what? Even. Okay, good. Thank you very much. Make sure that you subscribe. Bye bye. See you in the next video.